Hey everyone, welcome. Today we are going to look into a design principle called composition. Basically, composition means that a class contains instances of other classes that implement the desired functionality rather than inheriting functionality from a parent class. What this means is that think of composition as a Lego block, and we combine different Lego blocks to build something that is flexible. We can change it, and instead of creating one big Lego piece, we create that with small Lego pieces. Basically, composition is called has a relationship, and while inheritance is called is a relationship. What this means in simple terms, for example, let's take the analogy of a car and an engine. So a car is an engine. This is false. A car has an engine. This is true. So this is the basic analogy of has a and is a. And this is the essence of composition. Now, if we look at Lego blocks in detail, then as you can see, only with three specialized pieces we can create many different variations. So this is the whole idea behind composition. Now let's look at the problems with inheritance and the problems that we can solve with composition. So let's look at this example code over here. The first problem is known as the fragile base class problem. What this problem basically means that let's say that we have a base class called base calculator. It has a variable called value and two public functions. We made them virtual so that we can override them in the child class. So now this child class called special calculator inherits the base calculator. So we have access to this functionality. Now we have an operation count, and here we have an override. Now this override add will break or might break the functionality of the base class. So if we call the base.add number, this will call this add function, which will add the number to the value, and we would say operation count plus plus. Why would this code break? The reason that this would break is that if we change the functionality of the base class, let's say that we want to add more than one number. We add another number here, integer num. Now we will get an error over here and we need to make the change here and we need to pass a second parameter here as well. So changing the base class's functionality would basically break the functionality of the child class, or the making a change to any function would basically make you change the child class function as well. Now, in terms of this simple example, this might sound as this is not a big issue and sounds really simple. But think if you let's take a look at it in terms of a game. So think you have many types of enemies and they all inherit from a base enemy class. Now, if you make a change to the base class, you need to make a change to all those enemy classes, which is not a valid approach and wastes a lot of time and is prone to create a lot of errors. Now, the second issue is the diamond problem. While C# doesn't allow multiple inheritance, but just for the purpose of explanation, let's say that why the multiple inheritance is problematic. Let's say that we have an interface called flying and we have an interface called iShape. Now both of them have this same fly method. Now if we extend from both of them, then which fly method should we use? This is known as the diamond problem. Basically, we are in a closed loop and we don't know which one should we use. Next is the problem with tight coupling. We have a tight dependencies between the parent and child classes. Let's say we have this simple database logger which just simply prints a message to the console. Now this enhanced logger implements this base class, and let's say that we override the log message. Now we are tightly coupled to the database's logger implementation, meaning here we would basically console.writeLine and print the message. But what if we want to log to a file? So this is the issue of the tight coupling that arises with inheritance. Now the next one is the inflexible hierarchy problem. Let's say that we have a vehicle class and it has a move function which simply prints a message called moving. Now a car is a vehicle, and let's say that we create another function over here called start engine, and this would start an engine. Now a bicycle, it doesn't have an engine, but it inherits from the engine related code. Now if we inherit from vehicle, we have access to start engine, but a bicycle doesn't have an engine, but it is a vehicle. So we are forced to inherit inappropriate methods. So this is the inflexible hierarchy problem. Now the biggest problem that is faced is known as the deep inheritance chain problem. Let's say that we have these classes, a base class entity, a living class that basically inherits entity, then animal inherits living, then mammal inherits animal, and you get the picture. Now, let's say in the cat class, we have something that we want to look at. We would have to look at all of this hierarchy, which is a very big problem and wastes a lot of time. And this is one of the biggest problems with inheritance. Now, the next problem is the refused bequest problem. Now, let's say we have a bird, it can fly, it can basically says a message flying high. Now, an ostrich is a bird, but it can't fly. But if we inherit from bird, we have access to the fly method, and we need to implement this. And this basically breaks the solid principles as well. So this is also against the solid principles, meaning we shouldn't use an approach like this. So there are many problems with inheritance. It's not all bad, but there you should basically think really hard whether you want to use inheritance or not. If you have a proper use case, use it only then. Now let's look at the composition and how these problems are solved with composition. So let's now solve the problems we had with inheritance using composition. So first problem we had was the fragile base class problem, and instead of inheritance we will use composition with interfaces. Now first of all we'll create an interface iCalculator which has a method called add and an integer get value, and we'll create another interface operation counter. Now each of them has the functionality enclosed within themselves, meaning if we want a basic calculator, we'll just implement the iCalculator like here and implement these methods. Now if we also want the operation counter functionality on our calculator, we'll implement that interface as well. And now we will have a calculator with a counter. We have access to the add functionality, get value, and get operation count. So now if we change this base class, for instance, if we add a function over here or something over here, it will not break our code. Meaning a change in functionality of the base class will not necessarily break the code in the child classes. So the fragile base class problem is solved using interfaces by breaking functionality into small focused interfaces, and each behavior is encapsulated in its own class. Changes in one behavior don't affect others, and the classes will basically combine the functionality they need. Now, the next problem we had was solving multiple inheritance problems. Now, we'll break down behaviors into interfaces and compose them like we have a flying behavior, we have a space travel behavior, and now if we have a flight, we'll use a flying behavior. If we have a space travel class, we'll use the space travel. And how do we compose them? Let's say we have a spaceship. We'll have access to the flying, ni space travel behaviors, and in the constructor we'll inject the behaviors. So the spaceship will have access to the flight behavior and the space travel behavior. And if we call the fly function, now any class that is implementing the flight behavior, regardless of our spaceship class knowing that class, it will execute the function of that class. Meaning, let's say that we have a rocket class. Let's just say we have a rocket class and it has a fly function. It basically implements the flying interface and it shows a message hello. Now here if we pass our rocket and we call the flight behavior.fly, it will show us hello. And if we pass the space travel, it will show us traveling through space. So our main class doesn't have to know who is calling it. It just needs to implement this interface. So the problem of tight coupling is solved by depending on interfaces. Basically, it's called composition, you can say. And components are loosely coupled through interfaces and easy to swap implementations without changing or consuming classes. This also makes testing easy. Now, the next problem is inflexible design, meaning tight coupling. So instead of inheritance, we use interfaces based compositions for logging. Let's say we have an interface for logger, which is a database which is used by the database logger, and then we have a file logger. It also uses the ilogger, but it has its own implementation now. It will log the message to a file, and in order to use both of them, let's create a logging service. Now, if we call this using the file logger, it will output to a file, and if we call it using the database logger, it will debug to the console. So this solves the problem of tight coupling, and we can easily add more services here. Let's say that we want to log to a specialized folder inside a class, so we can create a class called specialized file logger in a specific place and basically write our implementation, and we don't have to change anything over here. This will still work the same way. So this solved the problem of tight coupling, and we can add more functionality as we want to. Now the next problem was the inflexible hierarchy. So this will also be solved using interfaces. So we have an eye movement behavior, eye engine behavior. If we have wheel movement, we'll say moving on wheels. And if we have pedal movement, we'll say moving by pedaling. Now, both of our cycle and car in terms of inheritance were using an engine, but a cycle doesn't have an engine. So let's look how this is solved. So first of all, we have a public class car2. Now this will have engine and movement behavior because a car has an engine and it moves. Now the next class we'll have is a bicycle. So this will only have movement behavior because a cycle doesn't have an engine, but it still moves through pedaling. So we will only use the eye movement behavior, and for car we'll use both of them. So our design is more flexible and the hierarchy is also flexible. Now the biggest problem was the deep inheritance problem. And this is one of the biggest problems that is solved by composition, and that is why you should favor composition over inheritance over here. So let's look at the interface. Breeding, they can reproduce, hunting, hunt, and eye pouring, they can pour. Now a cat can breed, it can hunt, and it can pour. So let's look at public cat2. In the constructor, we inject our behaviors and we basically implement the functions. This behavior allowed us to basically add the functionality that we want to. Let's look at a bird. For instance, we have a public class called bird. And now a bird can only, some birds can hunt. And for our bird, let's say that it's a small bird and it can't hunt, but it can reproduce. So for our public class bird, we will have a class. Then inside that, we will only be saying that private void read only hunting behavior. And that way, we will only have access to the hunting behavior. And if our bird class has a problem, we know that it only has a reproduction behavior, then we will only look at that reproduction part of the code, and that basically saves us time, and it is really easy to test that way instead of looking at the whole chain of dependencies. Now let's look at the final problem that we can solve with composition is the refused bequest. Compose only the behaviors that make sense. Let's say that we have an iMovable interface and the flying behavior implements iMovable, and if the flying object moves, it means that it is basically moving by flying in the air. And the running behavior is also basically moving, but it's moving using the ground. So if we have a bird and it has a movement behavior, and if we implement this, it basically means that we are moving through the air since it's a bird. Now let's look at how we use this. We have an eagle, we have an ostrich. If we use eagle.move in our eagle class, it's going to the air. If we have an ostrich class and we look at the ostrich, it moves on the ground. So we can basically compose our own behaviors without depending on the base classes. So these are the problems that are solved using composition, and the problems with inheritance, as you saw, were basically deep hierarchy problems, and that is the biggest problem that is solved by composition. Inheritance in itself is not bad, but you should clearly define your requirements whether inheritance is good for that or not. I hope you guys enjoyed this video. I'll see you in the next one.